Hi guys, in today's tutorial I'll be looking at how to design a reinforced concrete building using Prota structures. We'll be using this example as shown on the screen. So we have a 3 by 3 bay floor plan and we are taking it as a residential building floor plan or layout. So the beam sizes are all 250 by 600 mm and then the slab thickness is 150 mm throughout. Right. So in order to export this drawing to Prota structures, we'd have to first of all delete some of the elements within the layout because Prota structures cannot recognize them. So first of all, we'll delete the text, the labels of the beams, and then the labeling of the slab dimension as well. And then again, we'll delete the beam layout drawings as well, or the beam drawings. So first of all, we can select any beam label. So I'll select this one, right click. But before you do that, you make sure you've deleted every drawing within the drawing workspace or the AutoCAD workspace. Then you can now select any beam text, just one of it, and then right click, do select similar, and you realize all the beam text or labels have been selected. You can now delete. We'll do the same thing for the slab label. So I'll select this. Now select one, right click, select similar, and delete. Again, I'll delete the grid circles as well, and then the dimensions as well. Okay, the next thing we are going to do is to delete the beam outlines. Okay, so I'll just select one, right click, select similar, and delete. So we will now be left with this, just the grid lines and then the column. Finally, we would have to delete the hatch within the columns. Again, Prota structures can't recognize the hatch, so we'd have to delete all the hatches within the columns. So we'll just select one of the hatch, right click, select similar, and delete. And then we can delete this void sign as well. Now, this is what we have. So you just select one of the column, right click, select similar. You realize all the columns have been highlighted, but there's a columns, but we omitted a column here. So let's copy one of these columns here and place it here. Now, so this is what we have. Again, when you select the grid line, any one of them, and you select similar, you realize all the grid lines have been selected, and then you would have the layer on the grid line. Yeah. Now the next thing we are going to do is to save the file. So we'll head on to the top extreme left where we have this AutoCAD sign here. Click on that and then save as. We can now give the project a name. So we can save it as, let's say, Prota residential building, and you can give it any name you want, and then we'll choose AutoCAD 2013 DXF file. Right. Okay, you make sure it doesn't have any extension, so you delete the .txf, and then you indicate your folder directory. In this case, I'll be saving it in the folder in the documents folder. So you can now click on save, you close, and now you can go ahead and run your Prota structure. Okay, so it's loaded now. So we can now go to new project. So you click on that, and then let's give it a project name. So proposed residential building. You can't leave a space. What you can do is you do an underscore. So proposed residential building or the client name, whichever way you want to save it to remember. So you do, then you click on. So yes, we forgot one thing. We need to select the code that we'll be working with. So I'll be using UKBS 8110. So I'll select that, and then I'll say click on OK. Now we are going to import the drawing we saved in AutoCAD, that's the DXF file, into our Prota structure software. So what we are going to do is to click on the external reference drawing. So you click here, and then you come to the button down here, add. So you click on that, and you browse to the folder directory where you save the file. So I'm in my document folder, and this is my file. I'll click on it, and then open. And then the next thing, you click on this button here, the import button. And then with these ones, you can leave them as they are, these default settings. So you leave them as they are, and then you click on import. Right, then we can close this. So our drawing has been imported here. We have the columns and then the grid lines, but the grid lines are not what we expect, so we can edit them to suit our drawing. So when we check our drawing, the grid lines are A, B, C, D, and then on the horizontal grid lines we have 1, 2, 3, and 4. So you double click on this grid line here, so double click on that, and then you change the text to A. Change it to A. You do update. You do the same for this grid line, so that will be B. Update. Same for this C. Update. Update. Do the same for the horizontal grid lines as well. So that will be 1. Update. Right, so we've been able to adjust the grid lines to suit our drawing. So we have A to D on the vertical axis, and then 1 to 4 on the horizontal axis. Right, so the next thing we are going to do is to draw our beams on the grid lines, okay? And per our drawing, so all the beams are 250 by 600, and then the slab thickness is also 150. So let's head here, and then we'll go to modeling, the modeling tab here. So you click on that, and then you select beam. So this button at the top here, you click on that. So you click on that, and then we'll change the beam weight is 250, so that is fine. The beam depth is 600, so this will be 600, and then we'll select the orientation. So we'll select this one here, and we want the beam centered, so we'll select this option. Alright, so you have these 3 options to choose from, but I'm choosing the centered option. So I'll click on this, and then you click on the first column here. You extend it all the way to the end. You can do the same for this side as well. Then you repeat it in the next grid line. It's very simple. Okay, great. So once we are done with that, we will now draw the slab panels within the layout. So head on to modeling, the modeling tab at the top here, and then we'll select this button, slab button here. So you select it, and then so this is the slab thickness. So change it to 150. That is our slab thickness. The cover to reinforcement, we'll leave it as 25 mm. Then we'll head on to the loadings tab. So we go to the loadings, And then once you input the thickness of the slab, right, the self weight of the slab will be calculated. So that is what we have here, 3.6 kilonewton per square meter. And as we know, to get the self weight is the thickness of the slab multiplied by the density of concrete. That would give us this value here, right? So that is that. And then would have to add the additional dead load. So Prota has made it simple for us. Once we are able to identify the rooms or the space that we are looking for the additional dead load, to be able to give us a value of our additional dead load. You can either do it manually or you choose from within this the drop down list here. So I'll say room. Okay, and then you have this value here. Okay, so that will be so our total dead load will be the summation of this value, the 2.375 and then the 3.6. And then our post load or our life load, we are taking it as a residential building. So we'll do 1.5 kilonewton per square meter. So 1.5 kilonewton per square meter. And then the roof load, we are taking the roof as inaccessible. So we are taking it as 0.75 kilonewton per square meter. We don't have any snow load, but and then wind load. But in a situation where you are designing for these parameters, you can put your values there. But I'm not designing for snow load as well as wind load, right? So, okay, then you click on update and close. So now you can place the slab panels within the panel. So you click within the panels and then you just place it in there. But looking at our drawing, we have a void somewhere. So that void is in the middle here, right? So we have a void in the middle here. So we don't have any slab there. So we can delete this one. And then we have our layout done. Okay. So the next thing we have to do is to repeat this floor plan to the other floors. And in our example, we are doing a 3-level building. So ground floor, first floor, second floor, and then roof. So we would have to repeat this beam layout or floor plan to the other floors. That's the first floor, the second floor, and then the roof. And then eventually we would have to edit the roof to suit our beam members or roof beam layout. Okay, so to do that, we would head on to. So now that we've been able to insert the slab panels within the layout, we can head on to the Views tab and then look at the 3D model of the building. So select this one, 3D physical model. And then, so there's a 3D model as shown. So this is a 3D model as shown on the screen. Now, the next thing we are going to do is to specify our load combinations for the design. So let's go back to the floor plan. So we'll go to views and then we'll do story 1. We'll click on story 1 plan. Okay. And then we'll go to modeling. We'll go to loading. Okay. And then load case. We'll click on load cases and combinations. Right. So and then we'll come here loading generator at the bottom. So we'll click on that button and then we'll specify our vertical load combinations as well as the horizontal load combinations. So the vertical load combination comprises the gravitational loads, i.e. the dead and the life loads, and then the horizontal will comprise the wind loading, notional loading, or seismic loading. In this case, I would just be doing wind loading, right? So let's start off with the vertical loading. So you click on this one. You want a combination for the dead load cases and then the live load cases. So you click on this one, you highlight those ones, and then also you want to define combination for live load. I wouldn't want to do that. I don't want any combination for the snow load as well as the rain loading. So I don't want any stage cases as well as temperature loading. So these highlighted load cases are okay for me, and define pattern loads automatically. Alright, that is fine. Direction dependent pattern loading, that is also fine. And then these are the partial factors of safety. So 1.4 for the dead load and then 1.6 for the live load. So you can see at the top here, right now you can see at the top here. So as it stands now, we have 10 vertical load cases and then 2 horizontal load cases. So if everything is fine, or if everything is per your preference, you can click on the OK button down here, and then so these are all the load cases that you are applying on the structure. Okay, and then you click on OK. Now we are going to repeat this floor layout as well as its loading to the subsequent floors. So that is on the first floor, second floor, and then on the roof. But later on, we would edit the roof loadings, right? So in order to repeat this floor plan, we would go to building set out, and then we'll come to this tab at the top right. We'll click on it, and then we'll click on story operations, and then we'll say insert story. So our structure is a 3 level, so ground, first, second, and roof. So we'll say 4. Okay, and then we'll click on OK. Yes. Okay, then we'll go to that same button again, the stories button again. We'll click on that story operations, generate story, and then we'll click on this story 1 here. So you click on that, and you'll realize it has moved to the right. So you click on story 2, control story 3, and then story 4. So this means we are replicating the physical properties of story 1 to story 2, story 3, and then story 4. So then come here and then click OK. Alright, so that is done. So let's go to our 3D view. So come to the views button here, right click on that, and you select 3D physical model. Okay, so this is our 3D view now. This is where we've got into currently. But on our roof, we don't have any slab there. It's just the roof beams, right? And then we have the roof on it. So we'd have to delete the slab panels here. You can either do it on the 3D model, or you go to story 4, or you go to the views, right? So this story 4, you can either delete it here, right? You can either delete the slabs here, or you go to the 3D model and you delete it directly on the 3D model. Okay, so this is where we've got into now. Now the beams, the roof beam sizes are different from the floor beam sizes. Okay, so we want to use 300 by 150 for the roof beams. So we'll have to edit that. We want to change the beam sizes of the roof. We want to change the roof beam sizes. Okay, they are different from the floor beam sizes. So we would come to the left here and then click on beams, and then we'll right click, and then we click on beam table, Right, so the width of our beam is 150 mm. So you click this section here, that's the width of the beam. So you come to the top here, click on that, and you click on this button here, the clockwise edit. So you click on that and then you change it to 150. You can manually type it or you select it from the drop down list. So 150 and then okay. So you realize they've changed, and then the depth also will change that, and the depth also will change that. So you select this column here. With the depth also we'll change it to 300. So you select this column and then you click on this button and then you change it to 300. So okay, so those ones have also changed now. And then we'll say close. So when you look at the model, you realize the beam sizes have changed now. Okay, so we are fine with that now. Now the next thing we are going to do is to do the analysis of the building. So we'll go to analysis. So we'll go to analysis, the analysis tab, and then we'll head on to the building analysis tab. So you click on it, and then so at this point you can come. So at this point we are going to specify the material properties of our building, right? So at this side we have the grade of concrete, and then on the right side we have the grade of steel. So that's our tensile steel, and then the characteristic strength of our concrete, right? So we'll go to edit materials, okay, and then with the columns we are using C25, right? So a compressive strength of 25 Newton per millimeter squared. So we'll select that, right? So that is this. So C25 30, and then the button here, there's an option to apply this concrete strength to all the structural elements. So the slab, the the column bases, the beams, right? So it would say apply to all members of this material class in the story. So if you have maybe the foundation, you are designing it as C35, then this option will not work. You would have to manually do it for all the structural elements. But in this case, I'm using C25 for all the structural elements. So I'll click on this button here, apply to all members of this material class in the story. And then I'll say okay. Right, so you can see the columns have a strength of C25 30. Same applies to the beams, the beams and the slab. Then we'll do the same for the characteristic strength of the steel. So you click on the first one, which is the column, and then you can specify the strength here. So I'm using mild steel, so grade 250, and then again I'll apply it to all the structural elements. So you realize it's 250 throughout for the columns, the beams. So this means that the reinforcement that we'll be using for the columns, the beams, the slab are all mild steel. Okay. And then the next thing is to specify the rebar diameters for the structural elements. So we'll start off with the columns. So we'll click on the rebar diameter, and then for my columns I am using 16 mm, right? But I would want to give some allowance for 20 mm as well, in case the 16 mm doesn't work for some of the columns. Then I'm telling Prota to move to the next available reinforcement I've specified, that is the 20 mm. So I'll be using 16 mm and 20 mm for my column design, right? So I'll select those, so 16 mm and 20 mm, and then I'll turn off these ones. Okay, so that is fine. And then I don't have any wall in my structure, but if you have a wall you can also specify their diameters there. So I'll move on to the concrete beams. So the rebar diameter I'll be using for my beams, I'll use the same 16 and 20 mm. So I'll turn these ones off. So 16 and 20, and then I'll turn the others. Okay, for my slab, I'll be using 12 mm. So 12 mm. Okay. And then my stirrups or the links, I'll be using 10 mm. And as I said previously, these are my preferences. If you can use your own diameter of reinforcement for the design. So I'm using 10 mm for my stirrups, right? And then okay, so these are for so the specification is for the slab, the beams, and the columns. So I'll move on to this button here, the foundation floor, and then specify the concrete strength as well as the reinforcement for the foundation design. And then also specify the soil bearing pressure. So for my foundation, I'm using C25. So I'll come here and then select C25. I'm using mild steel again, so I'll select that. And then the diameter of reinforcement, I'll use 16 and 20 mm. Right. Okay. And then my stirrup is 250. And then diameter is 10. So you can unselect all and then just select the 10 mm. That is also another way of doing it. So once we are done inputting the parameters of our design, we can move on to the analysis tab. So you click on this analysis tab here, and then you click on building analysis. Okay, you click on building analysis. So we want to do design for column or wall reinforcement. We want to do beam as well. Right, then you click on this button. So building analysis. So click on it and wait for it to run the analysis and do the design. Okay. Alright, so the analysis is done. So we can close this button here and close this as well. We can go to our views now, and then we can now check the design for the various structural elements. So, but before that, we would have to design the slab. So let us go to our story one plan. So story one plan. Yes. So we want to design the slab.